Hello, welcome to this video. In this video, we are going to discuss how to convert a three-tier architecture into OCI. It is always challenging to convert a traditional architecture into cloud model. In this example, we like to discuss how to convert a three-tier architecture having web server, application server, and database to cloud with all the OCI features relevant to this model. First of all, consider this simple diagram: client, which is connecting to the web server, which internally connects to the application server, which does the application logic and connects to the database to retrieve the records. Let's start moving this architecture into OCI. The first step towards this cloud architecture is to identify the region, the place, the geographic location where we want to place our architecture. So let's first decide the region. Let me take a APAC region, Mumbai. So I have chosen the region here, and then I will create my tenancy in OCI. And the first step to create the architecture is the networking. Networking is the heart of OCI, any cloud architecture. So first of all, we create the network. So here in OCI, we'll create the network as virtual cloud network, where we'll get the a CIDR range, which will be the bulk amount of the IP range. So once it is virtual created, we need to create the subnets. The subnets are the small group of VCN, virtual cloud network. It will be having a small CIDR range, that is subset CIDR range of whatever we have allocated to the VCN. So we have two kind of subnet, public and private. The public subnet, it will be having the public IP as well as the private IP. The private subnet will be having only the private IP. So we need to place the resources which require the public subnet, public IP into the public subnet, which are web server, and we'll place the servers which require only the private IP, means like it should not be open for the public access, that we'll place it in the private subnet. So you can see here, we will place the web servers into the public subnet and app servers into the private subnet and database in the private subnet. Here we have considered two web server, considering the load will be a bit high when we move to the cloud. So when we have the two multiple web servers, we need to have the load balancer that has been attached, and the private subnet also we have two app servers, and then both app servers connect to the database. Okay, so it's a simple architecture. Now we can say we have migrated our the three-tier architecture into the OCI. Now customers can connect to the load balancer IP. From there they can traverse the web server, and then it will do all the necessary things by connecting the app server and database. It will get the data. So at present we have migrated the architecture into OCI, but this is not enough, because we haven't done any improvisations in the architecture, nor we can say we haven't taken any cloud features into this architecture. Okay, let's start implementing one by one. The first feature we are talking about the auto scaling. We need to perform scaling of web server, app server based on the load. So that will be taken care by auto scaling. It does horizontal scaling. When the load increases at the web server or app server, it will create another the respective server, web server or app server, and it will attach to the load balancer. When the load goes down, it will identify the server which has the minimal load, and that will be removed from the load balancer. So it means by any time if the load increases, our performance, the application or app server performance is not going to reduce. It will be scaled up automatically, scaled down automatically based on the CPU as well as the memory utilization. The next feature we are talking about the firewall feature. We could say it's a security list and a route table. The security list are the firewall rules where we define the appropriate protocol as well as the appropriate port to be open to access the web server or app server. For an example, the public subnet, we have taken the security list. Here we'll define, say, outside clients, any customer from the internet should connect the web server at port 80. Then the security rule will be like protocol will be TCP and the port will be 80. So we'll be define the security list here, and we'll be define the router table. Route table defines how the access happens from web server to the outside network, where gateway come into the picture. So we have three gateways we have defined here. One is internet gateway, NAT gateway, and the service gateway. So web server which wants to connect to the outside network, it has to go via the internet gateway, which is defined in the route table, and the app server and database server, they also need to connect the outside network to download the patches to get some fixes. So that goes via the NAT gateway. The beauty of get not gateway is like it's going to be one side network. It means only the connection from private subnet to the outside world will be possible, but from the outside world no one can connect directly to the private subnet. So those rules will be defined on the route table, and as well as the security rule will be defined at the firewall level. If you take private subnet, the security list will allowing the communication only from the public subnet, I mean the web server. It won't allow connections from the outside world. So those will be defined in the security list. Since we have the DB at our environment, definitely we'll be taking the database backup. The database backup has to be stored in the object storage. So object storage is a public service, like how we access our Netflix videos or Prime videos, which are stored in the object storage. So basically, object storage to access that we don't require the credentials of the cloud vendor. You can imagine to access a Netflix video, we don't need the cloud credentials where it has been placed. Or for example, if you have a Prime Video, we don't need the credentials of AWS account to access the object storage because it's kind of a public storage. So whatever object will be placed in the object storage, it will be called a public storage. So anyone can access when we have the valid URL, valid kind of a access level. So here we have the database and its backup going to be stored in the object storage, which is a public storage. So the backup has to be encrypted. My backup has to be secure. That's where the service gateway come in the picture. When we access the DB access the object storage, it's going to be happen in a private channel. And VPN is the one we are going to connect from the customer data center to the OCI. It means like I am the hosting the application. I need to do some changes to the application. In that case, I should not go via the public subnet. I have to have the private connectivity to the my app server and database server, which happens via the VPN. It is a free. There is no charge for the using the VPN. And that goes via the dynamic routing gateway. The communication with the dynamic routing gateway will be defined at the route table. And this is won't be enough Mumbai center because we have need the DR. So we need to replicate the same setup in a different region. So here we choose the Hyderabad region. So Hyderabad region will create the same resources, and then we'll create the sync between these two. So to sync between Mumbai and Hyderabad region, we require a dedicated private connectivity that's happening via the remote peering gateway, and database sync happens via the data guard. Okay. And here the web server and app server sync has to happen by either our own mechanism like creating a script or using any third-party tools. So we need to sync between the app server and the web server, and also the thing like data guard will be managed automatically by the Oracle. And this is simple, yeah, like we just converted the traditional architecture into cloud, and we have added certain basic attributes to make this environment like perfect, like function perfectly, and also handle the unexpected disruptions. And this is something we have achieved the basic things. Now we need to add certain things in the security perspective. The first one is like we are going to add CDN, that is content delivery network, so which is going to have the static content of your web server, so that like the response time for your web server will be unique across the globe. And IAM, we need to define identity access management to define who is going to access my environment. And then the cloud guard is the one like which is going to protect our full cloud setup. It has the list of the allowed things and list of like which are not allowed, and when it identifies like certain things are not which is not like good for the cloud, then it will intimate the administrator through either mail or Slack or SMS. Also it has a mechanism to do the recovery. So as soon as it identifies something is abnormal is happening, it will take the action and it will rectify it. Yeah, for example, like if I define object storage here, database backup is stored in the object storage, so it should be a private one. Suppose mistakenly a public bucket has been created, then CloudGuard will action on it. It will intimate the administrator and also convert the public into the private one. Yeah, and WAF, that's web application firewall, so which is going to protect our web server. So that could be like abuse connection could happen to the web server. So it has a list of firewall rules. It has the list of algorithms which will try to protect our the web server communication. So for example, like we may want to do the extra check on the incoming connection, whether the human or the robot is accessing our web server. So we may need to access like request them to enter the random characters what we shown in the picture, or we can ask for to click the pictures where we look means like we'll look for to click the pictures which has a particular object. So that kind of the verification will happen via the WAF, and we do have encryption. We'll enable the encryption to access the web server app server, and there is the storage what it is going to use, and it could be encrypted either Oracle provided key or it could be provided with a custom managed key. And also we design the monitoring notification so that anything happens which is not good for the environment will be monitored and will be notified. And also we'll define the budget to say like how much cost, like how much consumption we expect for the particular environment. In case the consumption reaches the threshold limit, we'll be get notified. And also we can create a lot of custom monitoring matrices we can create to identify and monitor our environment. So so here we have almost design our simple three-tier architecture according to the cloud and OCI. So the same kind of we can do for other cloud as well. We need to only see like the proper resources in other clouds. There could be some naming changes with the other clouds. For example, object storage will be called in Azure as blob storage, in AWS called as S3. So we need to just replace the resource names according to that cloud. So this just an example of how we can convert our three-tier architecture to the cloud model. Thanks for watching. Thank you.